So you get a job to quote. You need to cut it, you need to measure it. Do you know how to make the most of your inspection dollars by pairing your inspection methods with the tolerances required by your customer? Welcome back to Machine Shop Tech Talk, where I bring you the techniques and technology you need to keep your spindles turning and earning. Today we're going to talk about measurement, specifically how to make sure you're investing your inspection dollars wisely. It can be a slippery slope inspecting your part. You don't want to over inspect and you don't want to under inspect. Now, when I started machining, the first part of the job interview process was to measure a part in the QC lab. I had to measure a turbine hub from a transmission, and we had to give tenths. Now, I corrected the inspector because he misread the tenth scale. So needless to say, I did get hired, I got the job. Later, as I worked my way into being a lead hand, I learned how to pair the right type of inspection with the tolerances required by the customer, because I realized that over inspecting parts with a really low tolerance and under inspecting parts with a really high tolerance would result in a lot of lost time, a lot of lost money, a whole bunch of other headaches that I want to save you from having. I was able to take jobs that I was losing money on, turn them into jobs that earned money. I took the jobs that were taking too long to get through the process, and I turned them into jobs that were actually finishing ahead of schedule. I took the really frustrating jobs that I didn't want to run, nobody wanted to run, and I turned them into jobs that everyone wanted to run because they were running in a predictable manner. Now, you might be thinking to yourself, Arthur, that sounds great, but how does it work? I don't think I'm over inspecting. I don't think I'm under inspecting. Maybe you're thinking the opposite. Maybe you're thinking you'd like to know. So I'm going to share these 3 questions I always asked myself and I continue to ask my customers to help them save time. The first one is, what type of feature is it and how big is it? Whether you're measuring a bore or across the flats on the outside of a part, maybe you're measuring surface finish, maybe you're measuring perpendicularity, a positional tolerance. These are all going to change what way you inspect, and depending on how tight they are depends on how you're going to inspect it. I had a customer who was buffing a surface to get an 8 micro-inch finish, and it was taking a lot of time. They were wondering how they could improve the burnishing process, the polishing process. Instead, I went in there and I asked him, well, how are you measuring it? He said, by eye, of course. So what I was able to do for him is I brought in a surf test. We gave it a demo. We inspected some of their samples the way that they're sending them out right now. And then we did some other samples at half the amount of time and less, just to see where they were falling. Since they've implemented this, they've been able to cut their polishing process in half, simply by getting the right tool to measure the job. Was the tool a bit of an investment? Yes, but it wasn't ridiculous. And now they're saving hours upon hours every single day. And they have the confidence to know that they're producing their parts to the tolerance required. As I just touched on with the surf test example, it's really important to know what tolerance you're working with. Tell me if you've ever seen this. You have a guy making a part to a 2/10 tolerance, and he's using something that measures to 4 decimal places, like a digital caliper, to measure it, but he didn't check the accuracy of that instrument. And if he had, he would have noticed that it only repeats within plus minus 2 thou. Or the opposite, you've got someone on the saw, they're making rough saw cuts, plus minus a 16th. I don't know if you've seen it, I know I have. They're using a micrometer. Something that can measure down to a micron, they're using to check plus minus a 16th. Again, it's that mismatch. Not all of us think about it, not all of us have that experience. That's why I'm trying to share it with you, so you can hopefully gain some benefit and you can help other people with this as well. Number 3 that we're going to talk about is frequency. Now, if you've only got to measure this once per day, maybe twice, once in the morning, once after lunch, It's going to change what instruments you use. Instead of, you make 60 pieces an hour and you've got to inspect this dimension every single time. There's ways to save time and save money by investing in different equipment for that high frequency inspection. It's not always the answer of a CMM. Sometimes they cost a lot less and they can be a lot faster to use. Things like air gauging. This is another great way to get extreme accuracy in a very fast manner. Now, the reason that it's really important that you take time to balance your inspection method to make sure you're only meeting the quality requirements is so that you can do a few things. One, you're going to save time. If you don't have to inspect it to as tight of a tolerance as you have been, you're going to be able to change the inspection method, save some time, save some cost to the component, save some cost to the tooling. Another reason is maybe you can push that faster. If you were maintaining that tolerance within a tenth, chances are you had to back down your speeds and feeds a little bit so you're a little less aggressive to put less stress into your material. If you actually had a 5 thou tolerance, that means you're going to be able to push your machine harder. You're going to be able to remove that material a little more aggressively because you don't have to worry so much about the stresses in the workpiece at that point. On the other side of the coin, we have, what if you weren't inspecting to the tolerance required by your customer? Maybe they were looking for a parallelism check within a couple tenths and you were using a straight edge and light. By making sure that you raise the standard of the inspection equipment that you are using for your highly toleranced parts, you're going to avoid things like scrap and customer returns. Rerunning those parts is not what anyone has to do. There's the cost of the material, the cost of the labor, and now whatever you had on the schedule has been pushed back out of the way. Now, after you've asked yourself those 3 questions and you have answers, you can usually match it up with something that works. Have you ever taken that chance to write up a quick inspection plan? This is a document where you can specify things like the tool to use, such as a caliper or a micrometer, and then the dimensions that you're checking with. You can also outline things like shoulder dimensions. Sometimes in finished turning operations, several shoulders are done with the same tool. Once you've verified the program and the process, it's possible to just measure one of those shoulders. Saving time's not a crime after all. My passion, what drives me, is I want to help shops keep their spindles turning and earning. I do this by introducing them to the technology and techniques that are going to help them reduce their overhead. This is going to let their companies grow, and it's going to help them hire more. By hiring more, they're contributing more to our economy. We're bringing more manufacturing back here to North America on our shores, and it's a win-win situation. If you ever come across a process you would like to save time in for inspection or tooling, feel free to shoot me an email below. This is what I'm here for. This is my call. This is my passion in life, and I want to help you save that money so you can avoid the pitfalls that sometimes cause shops to shut down by missing opportunities to improve. If you liked today's video, feel free to give me a click on that thumbs up button. If it didn't work for you, feel free to give me a click on that thumbs down button. Give me some feedback down below so that I can help you improve and grow. We can all work together by growing the community. Check out the social links below this tab. I'm on Facebook, Instagram, LinkedIn, as well as Twitter. Still learning that one. You can check me out on all those places. On Facebook, I'm trying to grow the community so we can bring forward ideas, so we can bring more value to help our economy thrive. If you thought this video was a great video and you want to share it with your friends, please click that share button. Help spread me around. Help me help more people. The more people that watch, the more people that get shown this video, the more people we can all help together. And of course, if you haven't clicked subscribe yet, I'm sure the button is floating around here somewhere. Click on that subscribe button. And until next time, keep your spindles turning.